So now we talk about the pultruded section of a footbridge. Okay, so it's just of a footbridge. I think it's the bridge itself. Okay. Anyway, so they're actually manufacturing the pultruded section. So it's same thing as the extruded section, but I think for composite it's called pultruded. So it's just only the cross section, either this shape or whatever shape it is. So the shape, size and finish. I want to emphasize on finish. Please remember the finishing things. Okay? But nonetheless, heading back, just take note that we are also still considering the design considerations. Alright, so these are the things that you want to design it. Okay? And therefore coming back for the footbridge, I think I no need to explain much of all this. Okay? Abrasion. How do you acquire abrasion? How do you have abrasion? Where does the abrasion comes from? I also don't know where is it. Yeah. Maybe it's between some of the, I also don't know how it, maybe I go and search. Oh, okay. Abrasion I think is because of the wind. Alright, because a long time this is certain surface, alright? So a long time the wind may flow and flow and flow and flow. We can actually like somewhat erode the thing. So the erosion and abrasion is somewhat the same meaning. So we actually erode away or abrasion away the parts. So therefore you coat it with certain epoxy to resist this type of abrasion that may occur. Yeah. And if you were to go into there, you can search for effect of, you can go to IR library, which I think is pretty good. So wow, it's, yeah, so you can just download. Alright, it's over here, it's really open source. Wow, it's really super big file. So it's talk about some civil engineering stuff, which is also quite cool, like concrete abrasion. Like you just search for bridge abrasion and then you just check it out, the PDF. It's quite cool. I don't know, in the future you may need it lah. Nonetheless, let's come back here. And then, so the loading path, static and bending and torsion loading, I didn't think I need to explain. As for static, is because the bridge is static, it didn't move, so there is a static bending. Okay. And balancing percentage of the unidirectional roving. Unidirectional roving is just this type of thing, and then it's a string thread. CSM is a chop stream mat, which is like a toilet paper type of thing I've keep on saying all along. So there's two types of how your fibers will come out of. So these are the two types. So you need to balance between choosing the percentage of them, I don't know why, and to determine this, and this allows you to determine the stiffness and strength of your materials lah. And how to determine the strength and stiffness, you use your mixture all again. It's a sandwich bag analysis again, and it's a loading, it's a static creep loading again, it's a fatigue. So your factor of safety is equals to 6 also. And this is it for the footbridge. Let's take a look of the lecture notes and see. Go to page 29. This is the footbridge. Okay. And materials design, I think you can check it out yourself. E-glass in isophytalic polyester resin. So it's a form of a resin with a special name. And dog bone section. Wow, let's see. Here, this is the dog bone section. I don't know which section. This is the H beam, I know. Okay, or some cross sectional. And over here, oh, okay, this is the dog bone, I think. Because the dog bone is something like that, right? So therefore, over here is slightly fatter, something like that. So I think this is the dog bone as they are trying to say. So the dog bone can be improved by having this type of thing, so that it can prevent some bending of this beam over here. This thing over here can be, sometimes they may bend. So I think this thing over here is trying to prevent the bending. Yeah. And benefits of using this type of method, or pultrusion, is that it is assembled within 2 weeks, or without the use of a crane. Wow. Okay. Low component weight and high strength and durability with low maintenance. So yeah, this method is like macam only. So you should take note of the benefits because they may ask you also about that. And this is the cross section, or it depends on what type of. Wow, what's that, man? Three-way connector. How the hell is it gonna connect? Flank. Oh, that more chim already. So your unidirectional roving is connected. So your roving, this is the 3D lah. This is the 3D mat. This is the chop stream mat like that, right? Because it's random align chop stream mat, for example. Then over here the rovings are set in this form. So it's a laminate, and chop stream mat again in this form. Hopefully you're pretty clear. So wow, if you use 100% rovings, your axial strength is pretty high. Alright, as you can see, I believe axial. So axial is only unidirectional, so it's like that. So if everything is roving, then it's just like that. If it's a 50% mat and 50% roving, alright, you'll have a strength in this direction and this direction, transverse. Alright, so there's a transverse loading. So over here, transverse loading is weakest. Okay, I know what it means already. So if you have 100% roving, it is strong in this direction, but weak in this direction. Alright, as you increase the number of chop stream mat, you can actually increase the transverse loading strength, while you significantly decrease the axial loading strength. As you can see, it's really deep. So your axial loading strength is greatly reduced if you have a 50% mat and 50% roving. So you need to adjust your thing such that is pretty good. Alright, so somewhere I believe you can have over here at least it's half of this, or maybe over here half of it is over here, maybe 3/4 or what. Yeah lor, it depends on how you want to arrange your stuff lah. It's the percentage. I'll not go through all this, it's really like chim only. Water absorption, I think you should take note of all the quality, all these points like density, strength, elasticity, tensile strength. You should take note of all this in case you may need it. Yeah, and so I think the key takeaway of that is the balancing between the unidirectional roving and the chop stream mat for your loading things. And then your factor of safety again, take note of is actually 6. Alright, and you require the surface coating, a very important one for the abrasion. Alright, I think this is all. And color to blend with the environment. Alright, so yeah lor. So these are the things that you should take note of. Okay, and I think this is it for the pultruded section for footbridge. See you soon.